Okay, in this part of 2.3, we're going to look at part 4 and part 5. And in part 4, we are solving and graphing simple compounds. So remember, compounds is when you have, for example, compound words, 2 words put into one. So we have 2 inequalities. They are brought together by a word. We have 2 words or 2 ways we can see it. If it's an or, it's going to say or. If it's an and, it's going to say and. Or they could be smushed, okay? So we're going to solve just like an equation. So let's look at this first one. Remember, your inequality symbol is just like an equal sign, so we want to get that 7x by itself. So I'm going to add 5 to both sides. 7x is greater than or equal to, and we have 70. I now want to get my x by itself, so I'm going to divide by 7. X is greater than or equal to 10. Because that 7 is positive, my sign stays the same. Over here, I need to get that negative 3x by itself, so I'm going to add 2 to both sides. Negative 3x is greater than or equal to 0. I have a lot of people stop here. This is not a stopping point. X is not by itself yet. So I'm going to divide by my negative 3. Because that 3 is negative, I do have to flip my sign, and we still get 0. In my answer, you do have to put the word or. Or has to drop down. If you do not put the word or, then it's not going to come out correctly. The other thing is, if you are following arrows or if you have taught yourself tips and tricks or whatever, these need to be in numerical order. These are not numerical order, so I'm just going to rewrite this. So I have x is less than or equal to 0, or x is greater than or equal to 10. And now I can graph it. Remember, or means I have to represent both situations. So I have to put both situations on my graph. So this first one, I'm going to have a closed dot because it's equal to 0. And I'm going to shade to the left. On my other one, I'm going to put a closed dot in my 10. I'm going to shade to the right. This is a normal or. Normal ors should go out. Okay, here's my next one. This is an and. These are our tricky ones, okay? I rewrite everything in between these symbols gets rewritten. So right now, I'm going to write that twice. We have 7x plus 6, and we have 7x plus 6. Here's the tricky part. On this side, I wrote the 7x first. It is eating the 7x plus 6, so I have to eat my 7x plus 6, and my 50, negative 50 goes straight down. On this side, it looks exactly the same, so I'm just going to drop my sign, and I'm going to drop my negative 8. From here, we can solve. So I'm going to subtract 6. 7x is greater than a negative 56. I'm going to divide negative 56 divided by 7. It's a positive 7, so my sign stays the same. And I get a negative 8. On my other one, I'm also going to subtract 6 because that 7x plus 6 is still the same. So 7x is less than negative 14. I'm going to divide by my 7. X is less than negative 2. These are in numerical order. 8 is a smaller number. Negative 2 is the bigger number. I do not re-smush these. I just write the word and in the middle. That's just personal preference. So now I'm going to graph it. I have an open dot on my negative 8. And I'm going in. I'm going to have an open dot on my negative 2. And I go to the left. On an and, if it's a normal situation, they are going to overlap. Number 18. Again, I am going to look for everything that's in the middle. There's my in the middle. I'm going to rewrite it. So I have 3x minus 6, 3x minus 6. On this side, since I put my box first, I have to flip my sign so it eats the same piece of information. So it's eating the 3x minus 6. You can see that. On this side, I rewrote that first. It's still going to stay first, so I just drop down my sign in my 15. From here, I'm going to add 6. 3x is greater than a negative 30. I'm going to divide by 3. X is greater than a negative 10. I'm going to go to my other side. I'm also going to add 6. 3x is greater than a negative 9. I'm going to divide by 3. X is greater than a negative 3. Okay, this one looks a little bit different. Okay, they are still in numerical order, but if you look at my arrows are pointing in the same direction. So just be careful. You want the overlap. So if I go here, I have a negative 10 open bubble and it's going this way. I also have a negative 3. That one's kind of hard to see. We're going to say it's right there. It is also going this way. You want the line that is going to be the overlap of all of them. That's the blue. The blue line overlaps in every area. So that is the final graph I'm going to put on my line graph. So that is a special because you're only seeing one of them. Okay, here's my last and. They're not squished, so we're just going to go through and solve. On this one, I need to add 1 to both sides. Negative 10x is less than, and it gives me 0. I am dividing by a negative, so that means my sign has to flip. X is greater than 0. I'm going to subtract 10 on my other one. Negative 3x is less than or equal to a negative 15. Because I'm dividing by a negative again, I have to flip my sign. So x is greater than or equal to 5. Okay, again, my arrows are going in that same direction this way. So I'm going to graph them below. I have a 0 open bubble going this way. I have a 5 closed bubble going this way. I'm going to graph the one on my 5 because it is where both of them overlap. The other thing, I don't know if anyone caught this, even though I'm asking you to graph, I still need the numerical answers, which is right here. I need to put the word and. And then on this one, I forgot to do that. So I'm just going to rewrite x is greater than a negative 10, and so it just is all in one line. Okay, so do not forget to put your ands and your ors. Okay, so this should be the last part of our lesson, and this is going to be our word problems. Just like with equations, our word problems tend to be the more complicated part of our notes. Okay, so let's take a look at these word problems. It says, each type of fish thrives in a specific range of temperatures. The optimum temperatures for sharks range from 18 degrees Celsius to 22 degrees Celsius. Write an inequality that represents the temperatures where the sharks thrive. Okay, so the very first thing is I know I'm going to have X and I'm going to have X because we have to have 2 of those. The next thing is I do have 2 numbers. I have 18 and I have 22. So the things that we don't know, we do not know our signs yet. We do not know what word we're using. So it says the optimum temperatures for sharks ranges from 18 degrees Celsius to 22. So if it's going to range, that means it has to be 18 or higher, which means we need to eat the X because 18 is the smallest, but they are saying it's okay for it to be 18. So I should have a greater than or equal to. If it's ranging to something, that means that 22 is the largest, so it needs to eat the 22, and it's going to be equal to. If you have trouble determining what this is, then make your number line. You technically only have to have two numbers. You need an 18 and you need a 22. If I were to graph this, I'm going to put a closed bubble and I'm going to go to the right. I'm going to put a closed bubble and go to the left. Whenever they go towards each other and cross like that, that is an and. So the word and needs to be written in between. Okay. Apparently I didn't change number 20. Oh, I did. Ooh, this is a good example. That threw me off. Everyone's probably looking at that like we're crazy math teachers. Okay. Each type of fish thrives in a specific range of temperatures. The optimum temperatures for sharks range from 18 degrees Celsius to 22 degrees Celsius. We already knew that. Write an inequality that represents the temperatures where the sharks will not thrive. So if this is where they're thriving, we need the opposite. So again, I'm still going to start with X and X. I'm still going to put my 18 and my 22. So we already know where they're going to thrive. We want it to be more than 18. So if I want the knots and we know it needs to be more than 18, that means in this one it needs to be less than 18. Also in this one, we said it could be 18. Since it can be 18 here, it cannot be over here. Okay, on this one, we said we wanted the warmest temperature to be 22. Well, if I wanted the warmest temperature to be 22 here, then that needs to be the opposite way. Again, since 22 was okay, this one cannot, which means since they're going in opposite directions, it is going to be an or situation. So we're going to have an or situation. I can't pause this. Okay, so let's look at our next one. Sorry guys, there's a really long pause there. Okay, 22. The recommended air pressure for the tires of a mountain bike is at least 35 pounds per square inch, but no more than 80 pounds per square inch. If the bike's tires have 24 pounds per square inch, what is the recommended range of air that you should put into the tires? Okay, so on this one, we have to start with what we already have. Right now, we already have 24. We know we're going to have to write two separate ones because we're working with compounds, and compounds means two. One, if you look, if this is what I have and I need to go to these two numbers, we obviously need to go up. It also says what we need to put into the tires. So if I'm putting something into the tires, that means it's going up. Okay. We know that we don't know what we're putting in, so there's my X. And we also know our totals. We have 35 and we have 80. So again, the very last thing that we're going to do is our signs. So at least. Anytime it says at least, that means that's going to be the smallest number, which means we do not eat our smaller number. And it is also going to have an equal to underneath. So 24 plus X is greater than or equal to 35. On here, it says no more than 80 pounds. 80 pounds is the most because they don't want more than that. They are okay with the 80 pounds. Okay, from here, we would solve it. So if you guys solved it, here's what we should get. X is greater than or equal to 11, and X is less than or equal to 56. If you look at my two arrows, they are pointing into each other. This is going to be an and. Let's do one more. A student can earn prizes depending on how many items he sells in a school fundraiser. So far, he has sold 34 items. He wants to earn a prize in category 4, which requires the students to sell 46 to 60 items. Write a compound inequality that would represent the range of items he can sell that would not allow him to meet his goal. Okay, so we're starting with what we know. We know he has sold 34 items. So I'm gonna put my 34 and my 34. Okay, we're still basing it off of him reaching these two numbers. So that means we know we're gonna have to add X to it. And then we need to reach 46 and 60 items. So in order for him to win, he needs to sell more than 46. So if we think about this, I'm going to grab a pencil so I can erase here in a second. If he wants in that category, more than 46 would be this. And if he got 46, then he would also win the prize. But that word right here is not. So it is easier to write the actual scenario and then go through and actually flip the sign. Since this was a greater than or equal to, my actual sign is going to be a less than. On the other side, 60 will get you that prize. Okay, so again, 60 is the most for that category. If I get 60, again, I'm still in that category. So this is if I was in that prize range. I do not want to be in that prize range, which means I'm flipping it and it's not equal to. Again, we would solve this. When we solve it, we get X is less than 12 and X is greater than 26. If you look, they're pointing away from each other. This is an OR situation. Okay, I do want to look at this last one because it is a teensy bit different than what we had. A store is offering a 30% or $30 discount on all color printers. Luis is looking at different color printers that range in the price from $175 to $260. Write and solve a compound inequality to find how much he can expect to spend before the discount. So we know that we're getting a discount of $30. So minus 30 minus 30. Well, we have to subtract that 30 from something, and we don't know what that is. So my X is going to go out front. The lowest printer is 175. The highest is 260. And he wants to range in between there. So he is okay with 175 being the lowest and spending 175. He is okay with the printer being the highest at 260. Okay, the reason I went over this one is because of that discount. Discount always means that we are subtracting.